is similar to question number 1, where there's like a skip that happens. So normally, usually in a question, they give you like, this is term 1, this is term 2, and then it gives you a sequence of numbers, right? Sometimes they skip numbers, so that's the case in question number 1. So it says, Susan joined a fitness class at her local gym. Into her workout, she incorporated a sit-up routine that followed an arithmetic sequence. So this is important, it's arithmetic. On the 6th day of the program, Susan performed 11 sit-ups. So we can say that term 6, which is day 6, she's performed 11 sit-ups. So term 6 is 11. So what we're going to see is our sequence is how many push-ups or how many sit-ups she did on a certain day. And then we also know on the 15th day, so term 15, she did 29 sit-ups. So that's the information they're giving us so far. Now, what the issue of this is we don't have term 1 and we don't know our common difference to take us from one term to the next term. So terms jump. So when we're looking at terms, this is what's usually happening. And then we're always adding or subtracting a number to get from one number to the next in an arithmetic sequence. So what I'll do is I'll show you how this works. So let's say I had term 6. Next would be term 7, term 8, term 9, term 10, 11, 12, 13, 14, and 15. I just want to visually show you what I'm doing. So to get from term 6 to term 7, I would have to add 1D, okay? So it would look like this. Term 6 plus 1D equals term 7. Well, we want to figure out how many common differences, how many letter Ds would I have to add to go from term 6 all the way to term 15. So all you have to do is say that that's 2, 3, 4, 5, 6, 7, 8, 9. So from term 6, you would have to add 9 common differences to get you to term 15. This is the fastest way to do this. Otherwise, you could go a longer approach, which is where you make the equation for both and you do like elimination or substitution. So that was like from our last unit with sequences and series. I mean, with systems of equations where you substitute one equation to the other. But this is way faster, this method that I'm going to show you. So now that I know that I need 9 common differences to take you from one term to the next, we're going to replace term 6 with 11. And term 15, we know that there's 29 push-ups being done on that day. And then by solving for D, I then solve for my common difference. So I'm going to subtract 11. So this becomes a regular kind of equation that I'm just solving for. In my calculator, 29 minus 11, I get 18. And then I'm going to divide that by 2, and I get, or divide that by 9, and I get that the common difference is 2. Okay, so once you find your common difference, now you still need to find your term 1. So this is always the case. If you don't have your common difference in arithmetic, or you don't have term 1, meaning what's the first term, or how many push-ups did she do on the first day, then you can't really answer this question with the general term. So the general term equation always needs term 1 and your common difference. So what I'll do is I'll use the formula that's on our formula sheet. This is the general form equation when you're talking about an arithmetic sequence. So we already know our D value, right? And we also know a Tn and N value. So we can use that because this is our N and this is our Tn value. Okay, so you can use either the term 6 or the term 15 to substitute. Well, we know that in a certain spot we have 11 sit-ups. We don't know what term 1 is, but we know that that happens on the 6th day, so 6 minus 1, and our common difference is 2. So all we have to do is solve for T1. 6 minus 1 is 5 multiplied by 2. So 11 equals term 1 plus 10, and then we're going to subtract 10 on both sides to get term 1 by itself. So term 1 is 1. Okay, so there you go. So that is what I need, because now we're going to write the general term equation. General term equation. This is what the question 8 actually wants. You had to do all this work just to get your D and your T1 value to fill this in. So your general term equation is now filling this equation in with your T1 and your D value and then simplifying the equation. So as you can see now, T1 is 1. Replace it with 1. N and Tn will be affected by what spot you're looking at. So we don't know that. A general term, it just means we're looking at any term. So we leave N and Tn as they are. Your common difference, replace with 2. Now we're just going to simplify the right side of the equation by distributing the 2 into the brackets. And then all we have to do is put the 1 and the negative 2 together, and that's our general term. So Tn, which is our general term, is equal to 2n, and then 1 minus 2 is minus 1. So that is the equation that they're looking for to represent your general term. So this can be used to solve for, let's say you wanted to know the how many sit-ups they did on the 20th day, how many sit-ups they did on the 50th day. So you could use this general term equation to solve for anything. So that helps you for B, because now they're saying is, if Susan's goal is to be able to do 100 sit-ups, on which day of her program will she accomplish this? Well, Tn is 100. They're telling you that in a specific day, she's done 100 sit-ups. So that is your Tn. What we're missing is, what day is it? So N. So you're going to use, you can use a general term equation, which is this that we previously solved for. So hopefully you did that correctly. And then your Tn is 100. And all you need to do is solve for N to get your answer for B. So I would add 1 to both sides. 101 equals 2n. And then we just need to divide by 2. So n equals approximately 50.5. So it's going to take about 50 and a half days. So we can say that 50 and a half days to reach 100 sit-ups. So that's like our little summary statement, okay? So normally for N, we're not allowed to have decimal values, but in this case, because it's a day, we can kind of have like a day and a half. So that does make sense in the situation, that it's not day 50 and it's not day 51. It's day 50 plus an extra half of a day. So that makes sense in this situation. Otherwise, normally we wouldn't have like numbers in between a sequence. So that's why it wouldn't make sense. Okay. So here it makes sense to have that decimal value. Okay. So as use that. So that's question 1 for you. If you're just popping in, never mind. Number 2, guys, number 2. So number 2, we have Jason, who entered in a Russian sledge jump competition in the Arctic Winter Games held by Yellowknife. Suppose that they prepare for this event. Jason starts training by jumping 2 sledges each day for the first week, 4 sledges. So as you can see, we're starting to create a sequence. So it's important to write down these numbers as you go. So we know that our first term is 2. So that's the first week. And then 4 sledges on our second week. So this is week 1, week 2. So I'm kind of describing it underneath it. And then we have 8 sledges on the third week, and so on. So if you look at these numbers, it's not adding to get from one term to the next. So this is a geometric sequence. So this is a geometric sequence, guys. So with geometric sequences, we're multiplying to get from term to term. So if you're just joining us, we're doing number 2 from the sequences and series assignment. So when we're talking about a geometric sequence, we're saying that this is an R value. And R is how you go from one term to the next. So if you look at it, to go from 2 to 4 and to go from 4 to 8, you had to multiply by 2. So that's your R value. Whatever you multiply to get from term 1 to term 2 or term 3 to term 4, etc., that is your common difference. So common difference. Okay, so once you find your R value, they're also telling us during the competition, Jason jumped 142 sledges. So we want to know at what week did he reach 142. So what we're trying to find is a TN. We don't know what week that occurred in. So we're trying to find out like what number in the sequence would be 142. So that's our question right now. So what we have so far is R. R is 2 because it's the common. This is called a common ratio. I don't know why I said common difference. Common ratio. Our first term is always labeled as T1. So in our case, our first term starts at 2. So that's the first number of the sequence. And what we don't know is our N value. So if we're talking about geometric sequences, on our formula sheet, we have a formula that is Tn equals T1 R to the power of N minus 1. So this is the formula we use when it's a geometric sequence, and we're just trying to find out, when does 142 happen in that sequence? When is this going to happen right there? 142, okay? So that is the equation that we would use for that. So we're going to substitute. In this case, our Tn we know is 142. Our T1 is 2. That's the first term of the sequence. Our R value is also 2 because you're multiplying by 2 to get from term to term. And then we have N minus 1. We don't know what the N value is. Okay, so this is going to be a common step when you go into 30-2 or 30-1. You're going to see this happen, and you're going to have to be able to solve for stuff like this. So what you do first to solve for a power is you need to get rid of coefficients. So you're going to start by dividing both of the sides by the coefficient of term 1, which is 2. So 142 divided by 2 is 71. Now we're going to do this nifty trick. This is something very new for you guys. You've never seen this before unless you've taken this course before. But you will see it next year for sure. If you're going to 30-2, 30-1, you're going to see this step occur. So what we do is to solve for a power, we actually insert something called log. So a logarithm is kind of the opposite of an exponent. So a logarithm is the opposite of an exponent. So what we do on one side, we do to the other. So I put a log on one side of the equation and a log on the other side of the equation. On your calculator, you have the button LOG. Do you guys see that? LOG on your graphing calculator? So look for that. That's the button that we're going to be using for this. Once you put the LOG, the log, in front of both sides, what's cool about this is when you introduce this log function, what it does is it brings powers down to be coefficients. So once you put the log 2 in, now you can actually bring the N minus 1 to be a coefficient of log 2, like that. So it's on the same level now. Now there's no powers. So it's a really cool step there. And then what we want to do is let's isolate for N by dividing both sides by log 2. So this is where we can use our calculator. So on your calculator, you would go to log 71, and then you would divide by log of, what number did I have again? Log of 2. So as you can see, I'm just using that LOG button. In brackets, I'm putting what's at the top divided by log of what's at the bottom, and I get this 6.15 number. So 6.15 approximately. So log 71 divided by log 2 is about 6.15, and that's N minus 1 now, okay? And then your last step is just to add 1 on both sides. So when you add 1, you get approximately 7.15. So when it comes to weeks, we could say this is approximately, between week 7 and week 8. So we can say if we want to, we can round up to 8 weeks. So it's going to take us approximately 8 weeks to reach this 142 sledges. Or if you want to have that number and say it's going to take us between 7 and 8 weeks, that would also be okay. Okay, so those are kind of answers I'm looking for there. So check if it's arithmetic or geometric. The previous one was arithmetic because we were adding to get from one term to the next. This one was geometric because we are multiplying to go from term to term. Okay, so that's what you need to do for question number 2 on your sequences and series assignment. So same kind of work, it's just different numbers, of course, with yours. So question number 3. Let's look at question number 3. Are there any questions so far before I go on though? So go in the chat, let me know guys if you have any questions so far about what I did, because there's that new kind of thing. You'll see that in the next question as well, that log feature. So you'll see that, I'll go over that once more in this question. Okay, so question number 3, guys, is in your assignment, it's a word problem. This one is just numbers. That was like the closest I could get to it. So you just have to take out the numbers and write out what it would look like in this form for like what I have. So you'd want to take out the first number. What would the first number of that sequence be? What would the second number be? What would the last number be? And it should look like something like this if you pull out some numbers, okay? And I'll just show you how to work with the numbers and how to solve for question number 3. So as you can see, mine is not a word problem, but it's the same amount of work, same steps, okay? So for this one, this is a geometric series. Okay, so we know that we're going to have to determine the sum, meaning how much will it add up to. So the sum formula looks like this when it's geometric. It's always Sn equals, actually, let me pull up my formula sheet. It's always going to be T1, and then it's r to the power of n minus 1 divided by r minus 1. Remember that the r is your common ratio. What are you multiplying to go from term to term? Your T1 is your first term, and then your n represents what spot are you in. Okay, so n, that little n is that what spot are you in? Are you in the third spot, fourth spot? What does it stand for? And then S represents the sum of what the numbers add up to. If you were to add up all these numbers in this sequence, what would they add up to? That's what the Sn stands for. So we do have a few things. We know that term 1 is 27. This is term 1, the first number in our sequence. Okay. We also know our R value. So our R value we can find by taking term 2 and dividing by term 1. Now you can do any numbers. You can take term 3 divided by term 2, as long as they're one after the other. So in this case, I can use 9 as term 2, and term 1 is 27, and we can simplify this to 1/3. So that's my common ratio as a fraction. Now it's important to leave it as a fraction when you substitute, because if you round it, that's going to keep rounding your answer until the end, right? So I'm going to put 1/3, and then my n, I don't know, because we don't know how many numbers are in the sequence. We don't know how many numbers will take us to this last term. So that's what's missing here. So this is a 2-step problem because I'm going to have to solve for n. And to solve for n, you're going to have to use that geometric sequence equation, which is this. So this is the equation we used previously in question number 2. If it's geometric, we can use this to find out how many spots there are in a certain question. So that's exactly what we did in question number 2. So let's find out what spot number this number is in, because if we can find out what spot number it is, we'll now know how many terms there are in total going up to that number. So let's say our Tn is 1/243. Our first term is 27. Our common ratio is 1/3. And then what we're missing is n minus 1. So just like in the previous question number 2, step 1 is dividing that T1 to both sides. So you're going to have to put that in brackets when you divide. So I'm going to put bracket 1 divided by 243 and we're going to divide by 27. Okay, so you can change it to a fraction. It's a large one if you want. It's 1 over 6561. So these guys cross each other off, leaving us with 1/3 to the power of n minus 1. Now, just like in the previous example, when we have to solve for a power, what I like to do is I introduce that log button. What I do to one side, I do to the other. Okay, so once I have log on both sides of the equation, now it's about bringing that power as a coefficient in front. So I bring that down, the n minus 1 power comes down and becomes just n minus 1 multiplied by log 1/3. And then log 1 over 6561, 6,561 stays as it is. Our next step is to divide both sides by this log 1/3. Oops. So I'm dividing both sides by log 1/3 to isolate for n. So those cross off. This is where I'm going to go to my calculator and put that in to see what I get. Okay, so press your log button. Then you're going to go in brackets 1 divided by 6,561. That's already closing your brackets. And then you're going to divide that answer by log of 1 divided by 3 in brackets. Okay, so you get your answer, and I get that it's a nice answer of 8. So that's really good. So I get 8. So like I said in the previous question, if it's a real life scenario, it's allowed to have decimal values for n, but if it's just numbers, it shouldn't have decimal values like this one. So lastly, I'm going to add 1 to both sides to get n by itself equaling 9. So now that I have n as 9, I'm going to go back to this sum equation and substitute 9 as n wherever it asks for it. So I'm solving for the sum of 9 terms. That's what I'm trying to do in my calculator. Okay, so BEDMAS is very important here, guys. So when you do this, I'll show you what I'm doing in my calculator so you guys can see this. So to put this into my calculator, 27 brackets. And then I'm putting another bracket around 1/3 because I'm going 1/3 to the power of 9. So I want the entire 1 divided by 3 taken to the power of 9. And then I'm going to subtract 1, close the brackets. I'm going to get the answer for this, okay? So a lot of people try to do it in one step and they usually make an error. So I usually try to solve for the top and then I'll solve for the bottom. And then I'm going to just divide those two answers. So remember, you have this button in your calculator where you can highlight and then divide by this answer instead of rewriting the entire answer. So I'm highlighting it, pressing enter, and it's just going to copy and paste it there for me. So when I divide my answers, I get about 40.50 to the nearest hundredth. Okay, so 40.50. So 40.50 is my answer for the sum of 9 terms, and that's what they're looking for. So in your same idea, you're going to have to solve for n, meaning how many levels are there in your kind of, I think it was like where they had to relay a message or something. So you have to figure out how many stages there are, how many n values there are. And then once you have n, then you go to this equation here and substitute your first term, your r, your n's in there, and then just solve for what the sum of that number of terms is. And that would be your final answer for this. So it's a 2-step problem here. Solve for n, solve for Sn. Okay, so any questions up to now, guys? Go into your chat, let me know if you're good, or if you need some more assistance or clarification of where I'm getting these numbers from or how I worked with it. What did I do in my calculator? Let me know.
Miss Hines, I'm back
Hey.
from the dead.
Good, I'm glad.
Yeah, really feels like I was dead. Ed, like, when are you free for like a Google Meet?
We can chat right after this if you don't mind.
Right after this?
Like
Okay.
when we're done, we can continue chatting and schedule something then if that's okay.
Okay.
Because there's only like one more question and then I'll just pause once everybody leaves, me and you can chat if that's okay.
Yeah.
Does that work?
Uh-huh.
Perfect. Okay. So let's finish up with question number 4. So this is similar to question 4. I tried to make it as similar to yours as possible. So I did rewrite the equation a little bit just to, just because that question was very, it was worded very interestingly where you have to think. So that's why I want to do this one a little bit more clearly with you guys. So question number 4. So when a doctor is prescribing medicine, what you need to remember is that your body metabolizes the drug gradually. After some period of time, only a certain amount of the drug remains in your body. So metabolizing is different from what's left in your body. So what your body's using is different from what's left. So that's kind of what you have to keep in your brain is what are they asking for? Are they asking for what your body has used, or are they asking for what is remaining after you've metabolized that drug? So suppose a person with an ear infection takes 200 milligrams of ampicillin tablets. The pill is metabolized or used up at a rate of 12% every hour. So 12% is being used up, meaning metabolized every hour. So we want to calculate how much of the pill is left. So after taking the third tablet. So what we kind of want to write down is this information here. So 12% of the pill is metabolized. Well, I encourage you to do this for your assignment too, is figure out what's metabolized. And if you take 1 minus, or actually it should be 100 minus 12%, what do you get? You get 88%. So this is how much is left over. Now, I just made these numbers up, so it's not really accurate to like a real life scenario here. I just kind of put in a number. Normally, you would metabolize more than that, right? You wouldn't want to have that much left over. But anyway, so 12% is metabolized, 88% is left still in your body, okay? So what they're asking for is, after 3 hours, how much is left over? Okay, so how much is left over? So what we have to do is we have to solve for, we're going to solve for, instead of the third tablet 2, I want to change this to 3 hours. So let's figure out how much after taking, so after 3 hours, how much is left? Yeah, that's going to be closer to your assignment. So after 3 hours, time is very important when it comes to sequences and series. So like if we're saying after 3 hours, well, that means more terms than normal. So let's say you started with like 5 milligrams and then you went down to like, then you went up to like 10, then 15, then 20, etc. So this would occur after 1 hour, right? So when you jump from term 1 to term 2, that is 1 hour of time. And then this would be term 2 to term 3 would be 2 hours. And term 3 to term 4 would be 3 hours. So what I want to point out here is that when we're talking about 3 hours, we actually are talking about 4 terms. There's a skip that happens. We always skip over something when we talk about time difference. Like, let's say I want to know how many years have passed from, if I want to say 2 years from now. Well, I wouldn't count this year. I would say 2 years from now would be 2022. Do you see how I jumped over 2020? I went to 21, 22. So that would be 3 terms. So there's always one more term than there is for time. Okay, so that's something I wanted to point out there. So that's the tricky part for this question. So when they say 3 hours, you have to solve for term 4. Now, we're multiplying to get from term to term, so we have to use that T1R to the power of n minus 1 formula, okay? Now, we want to know how much is left, so your R value needs to be the leftover value. So term 1 means how much medicine do we have in our body? Well, we start with 200 milligrams. How much is left? We need to take this percentage and divide it by 100. So it's going to be 0.88 for your R. Okay, that's the leftover amount. That's why I said you have to watch what the question's asking for. Are they asking for metabolized or what's left? So you need to use the right number. And then our N is 4 because it's 4 terms for 3 hours. So 4 minus 1. And then you would just put that into your calculator, and 200 times 0.88 to the power of 3, because 4 minus 1 is 3. So I get 136.29 milligrams is left over. So that would be your answer for this kind of question. So watch for the time to terms, jump, and then watch that you're using the right number for your R. So that's like the trick for this question 4 that might kind of help you. And then B, if the patient does not take another pill, how much of the pill will the patient use after an infinite number of time? So now they're saying how much of the pill will the patient use? This means how much have they metabolized? So do you see how the question has changed? Because they want to know how much the person has digested or taken with their body, and not what's left over anymore. So with this number, with this question here, we actually need to know the first term. We need to know how much has been metabolized by the body in 1 hour. I mean, like in the first moment, okay? So T1, we're going to have to solve for by using 200, which is your, so we're going to have to use that. So after 1 hour, meaning how much has been metabolized. So we know that 200 milligrams of pill has been ingested. And for metabolized, we're going to use that 12%. So 12%, if you divide that by 100, you get 0.12. So you're going to multiply it by 0.12, and that's going to be what the body used right there. So 200 times 0.12 gives us 24 milligrams. So in 1 hour, we've used 24 milligrams. Okay, so we're going to use that as our term 1 in this case. Okay, so it becomes a different kind of question, and that's why we have to switch and find this information first before we continue. Okay, so it's not about what is left over, it's about metabolized now. So now that we know our first term, they want to know the infinite number of time, infinite amount of time of the patient's usage, how much pill has been used, okay? So this is where we use the sum of the infinite equation. So the infinite sum is equal to always T1 over 1 minus R. So it's a really simple equation to use. We just had to figure out what term 1 was, and then we had to use the right number for R. So term 1 represents how much was metabolized after the first hour. We have 24 milligrams. Divided by 1 minus, how much is the body metabolizing over time? We know that that's 0.12 from what we found right there. Now you just have to put this into your calculator, but if you're doing it in one step, put brackets around your denominator. And so 24 divided by 1 minus 0.12. So what they're saying is, if you put this into your calculator, why am I getting a weird number? 24. Okay. Oh, nope, I'm good. How much of will the patient use? Yeah. So I'm good. So how much will they use? How much will they metabolize? Yeah. So what they're saying is it's going to be 27. It's just a weird number. I'm looking at it because it's a weird number, but this is why. It's a made up question here. So it's not really making like perfect sense. Like, so if you kept ingesting this, remember that the person is starting with first term 24 milligrams. They've ingested it. And we're saying like, how much over time will they ingest if they keep taking this amount in? Remember, the body is like getting rid of it. So they're only adding a little bit extra each time. So that's why the number is not that crazy, because we don't want to kill the patient. Okay. So here, 27.27 milligrams, it is what is left there. Yes. Okay, so that was all I wanted to show you guys for that. Are there any questions? So that last one is the one that you kind of have to like use your brain a little bit, but if you follow what I did, then you'll be fine. So guys, if you don't have any questions, good luck, and I hope you guys get this assignment in, and then you can rest and relax and enjoy the rest of your summer. I really, really, really enjoy teaching you, not so much online, but in class. I miss that time more. It's hard talking to a screen and then like not even seeing your faces, or talking to chat instead. Like, Jonathan's good all the time. Are you really good, Jonathan? Is my question. So let me know, guys, if you have any questions. Get this in, get this completed. So there's 4 questions, as you can see here. Use what I've given you, and then get that in so that hopefully your stress is done. And Alvin, good job. So let me know also if you did your Desmos. So Alvin did your Desmos. Did you see your mark, Alvin? Everything's good. So very impressive. So that was only if you wanted to replace a mark. That was, you could do Desmos. So Alvin chose to do that. If anybody else did that, let me know so that I do mark them and I don't ignore them, okay? Yusuf, where were you?
I woke up like 20 minutes ago. So
Oh man,
yeah,
those are funny.
that was
Okay.
my fault.
Yeah, so I'm recording this. I'm recording this, so if you want to then join in or watch the recording and then just ask me questions, because
Yeah.
I'm just finishing right now. Okay, so let me know. See that first, and then if you still have questions, feel free to message me and let me know, okay, if there's something you're stuck on. So the only question that you should kind of like could rake your brain is the last one, but the rest of them are very like straightforward, not much thinking. It's just doing exactly what you see or what you just saw me do, okay? So how are you feeling? Are you guys good? Are you guys excited to be done with math?
Isn't next year like much harder?
It is.
It
is. That's why this year is like the year, if you worked hard, then you're trying to like take off a little bit of burden for next year, right? Just a little bit. Like it's still difficult. It's a lot, because like I think the biggest jump is from 10C to 20-1. But then since your other courses, like, I don't know if you found, did you guys feel like chem and bio were easier this year, or easy in comparison? Because next year is their jump. So I find bio and chemistry do their jump from 11 to 12. So it's just a tough year with cores, because the cores are just, they expect a lot from you, and there's a lot of pressure. So you want to kind of keep on top of it and do whatever you can to minimize like the stress that you feel, right? Because stress doesn't help, as you can see, right? So, but I am available, of course, to if you want to message me, and then hopefully I see you guys next year. Who knows, I might teach you guys. I don't know what I'm teaching. We only find out like 2 days before you guys actually start in the school of what we're teaching. That's how crazy it is, because like schedules kind of mixing and that. We never know what we're teaching until like the second day before you guys come, and then it's like mad rush to like get everything organized. So who knows what I'll be teaching, and then I wish you guys luck, and I hope I did you justice, and I hope that you did enough work that you feel like you'll be okay. Like the teachers next year will understand that, but like they've canceled PATs. Like it would be nice if they canceled the diplomas for you guys next year, just to kind of have that stress relief as well, or that stress taking off your shoulders, and just focus on learning the material again. And then maybe the following year they can reintroduce the diplomas, but that's my opinion. My opinion doesn't matter, of course. So we'll see what happens. Whatever it is, like your teachers are gonna try to help you out as much as possible, and then just use them as a resource. Remember that. Okay, if you guys have any questions, stick on here. If not, then good luck. Again, I'm here, so get those assignments in, guys, and enjoy your summer, okay? Enjoy that weather. Hopefully it gets nicer each day, because it's been like terrible weather. But I think it's good for when you're in class and doing stuff, but it's not great for if you want to enjoy your summer. I don't know why I'm recording myself.